Can you hear me, Shravan?
Yes. Good afternoon.
Okay.
Yes, you are audible. Yeah.
Why there is no other people around? Why there is no coming in the class? Don't know.
Maybe we will wait for a minute.
Yes?
Maybe we can wait for a minute.
Yeah, yeah, yeah. 5 minutes.
Yeah.
I think no one is coming, so we can start, Shravan, if you want.
Yes, what's we can go ahead.
Yeah. Okay, so have you done the previous assignment if you have any doubts?
Yeah, it was cleared because actually last time I could take some time because it was slightly different from the classes, but we could see this. I think that last session is mainly from this week. Uh, Whatever we have given in the links, probably that is some minor change it was there, but actually we could do because of your class.
Yeah.
Probably here
So you
only.
were able to do the assignment from the questions I have discussed
Yes,
mostly.
yes, yes. Yeah, mostly whatever the questions we have discussed in your class, I think it was I was able to do it. Only one doubt is actually with
Yes.
respect to that command. Anyway, that was a mistake. I could not clearly see the question.
Okay.
It was like a second divided difference. It was asked.
Yeah, yeah, yeah,
So other
okay.
than this, all the other questions I could
Are the
answer.
tutorials helpful or no?
Pardon, pardon.
Are the tutorials helpful or not?
Yes, yes. Whatever because of your class only, I could do that.
Okay.
Otherwise, it
Otherwise,
would have been.
lectures, seeing the all time lectures and they are, yeah,
No, no,
like
no.
it's,
The difference is like last time, the lecture
yes,
was
yes.
not relevant to the questions. That was slightly some, I don't know how it happened,
Okay.
but
Yeah.
because of your this sessions, I could manage.
Yeah, yeah. That's why they are doing that. Okay, we can discuss this, Grishkorin. I think I have not discussed power method and these whole things.
Yeah, yeah,
I
yeah.
can
It
discuss
was,
them maybe
yeah.
sometime. No one
And
is here, so
this time actually the assignment questions are more related to similar to what, maybe not similar. At least some questions are similar. Some questions are like maybe now we will be discussing. I hope.
okay, okay. The assignment 7 you are talking about, or
Yeah, for this week,
wait
and
a second.
this, yeah,
Okay. Actually, I'm opening the book for MK Jan and the Grishkorin theorem, and I'm trying to explain it. Have you seen in the lectures this theorem? What does it tell about? No.
can you
Is it
please
all
read that?
discussed in the lectures? I'm
Yes,
not
yes,
sure.
Grishkorin theorem was discussed, but 1 week before.
Okay. So should I
However,
recall it once?
yeah, please, please, please.
That would be good.
Yeah.
Okay. So what does the theorem says? Let me write. I just recall it. Yes, right. So what does it say? It says that largest eigenvalue in modulus of the square matrix. Okay, so modulus of, I should write modulus of the largest eigenvalue of the square matrix A can't exceed. Please note that can't exceed the largest sum of the moduli of the elements along any row or any column. Okay, so do you understand this statement?
Yeah.
What does it tell about? Yes.
Yeah, it was like for any row, whatever it is, the row addition.
Yeah.
For example, first row, second row, or third row, with what we can say like modulus value, if we are adding, the
Yeah, yeah. So you are trying to find the
will be within the
modulus
bound, like
sum
upper
of
limit.
the each elements in the row. Okay, I just explained
Exactly,
it.
exactly. Yeah, yeah. Yeah.
Some moduli elements. Okay, on any row or column. Okay, so suppose it is a matrix like A11 and A1n, AN1, so, so forth, whatever. So this is the first row. This is row. Column is this one. So what does it say? It says that if lambda I is eigenvalue of A, then modulus of lambda I should be less than equal to the, what we say, that this sum, right? A11. Am I right?
Yeah, yeah.
Yeah. Is it less than equal to every row sum? So it's modulus of largest eigenvalue.
Yeah.
And lambda I is the largest one. Lambda I is the largest. Okay, so if largest eigenvalue is less than equal to that, then all eigenvalues will be less than equal to, right?
Yeah.
Largest sum of the moduli of the elements along any row or any column. Okay. So what you can gather is, okay, so it is clear that if largest eigenvalue is less than equal to the sum, then each eigenvalue modulus will be less than equal to the sum of the moduli of elements along any row or any column. Okay, the question is, what does this statement mean? Exceed the largest sum of moduli of elements. What do you mean by this one? Can't exceed the largest sum.
When we add this elements, whatever the value we are getting,
Yes.
like the eigenvalue should be within that range. Like it will not cross, it will not be above this, or
Yeah.
it will not be more than this. It will be less than this addition of this sum of rows or columns.
I mean, okay, so xk, what does, okay, let me see. This is not basically, it is not less than equal to the every row sum, you know? It's not less than equal to every row sum, every column sum. It says about the exceed the largest sum of the moduli. So you have to search for which row the modulus sum has the largest. So you can't write k, so you write k. Okay?
Okay, okay, okay. So is it like
Yes.
okay, which among these rows, which one is the largest? Correct.
Yeah,
Okay, I got
kth
your
row
point. Yeah, yeah,
has
yeah,
largest sum.
yeah, yeah.
That's fine.
Clear, clear. So which one is the largest row, and the eigenvalue should not be will not be more than that.
Yes.
Yeah,
Okay.
yeah. Okay.
And like for column sum also you can say.
Columns also. Okay, okay.
But I think I'm talking about row sum. Okay.
The
Anyway,
rows. Yeah, yeah.
but you can use anyways. Okay, so can we have a question? Or you know the proof of it? I should not discuss it, right? Because
Yeah,
it's
it
in
is.
the lecture.
Yeah, it is discussed in the lecture.
Okay, okay. So let me write another theorem, a basic theorem, maybe that would be helpful. This is another theorem which says that there is a theorem which says in solving question, let pk be the sum of moduli of elements along the kth row. Okay, let pk be the sum of the moduli of the elements along the kth row except the diagonal element akk, then every eigenvalue of A lies in or on or on the boundary of at least one of the circles. Okay. What are the circles? Lambda minus akk is less than equal. is equal to PKK. A is 1, 2. Okay, so what the theorem says, that is important one for solving questions, okay?
Yeah. Can
Let
we
Pk be the sum of the moduli of elements along the kth row, right? So
yeah.
like this is the Pk. You can see this? It's Pk.
Yeah. Yeah.
Accept the diagonal. Pk x, if you remove from akk, if you remove, like if you remove this sum, then it is Pk. Okay?
Okay. Without diagonal elements.
Yeah. Then every eigenvalue of A lies in or on the boundary of at least one of the circles. Yes. So every eigenvalue lies on the boundary of inside this circle or on the boundary. So what does it look like? Lambda minus akk is pkk. So lambda minus some, say 2 is 3, is equal to 3. Is it a circle or what? At least one of. If lambda is, you say, complex number, then it will be a circle. So you understand this statement?
But the
Or
statement is clear, like that PKK is the sum of the diagonal or the moduli of the elements in a row, and we have to remove the diagonal elements alone. That is first
yes.
point. Then every
Yeah.
eigenvalue of A lies in or on boundary of at least one of the circles.
Means it will lie in between any circle, like so pkk may change depending on the row sum. Different
Okay,
rows, different pkk, right?
correct.
So I'm
Okay,
talking about only rows here, not columns. But I think this is true for columns also, but we choose for rows. Anyways, so PKK may change depending on the rows, right? And AKK is also changing with the rows, right? With
okay,
different rows, you have different AKK. So how
correct.
many circles you have? Can you tell me? How many circles? How many circles we have? How many circles we have? If the matrix has dimension n, what is the number of circles? Because for every row we have PKK, right? Can you see?
Yeah,
We
yeah.
have n circles. Yeah.
Mm.
So in these n circles, there is at least one circle in which this eigenvalue lie. Every eigenvalue of A lies in any of these n circles. Okay, let's
Okay,
see.
eigenvalues is within that n number of circles.
So now what is the use of this theorem? Can you tell me? It gives us the bounds on the eigenvalues because it's lying inside a circle.
Okay, okay.
So we can use this theorem for our. So for the given matrix, find the bounds for the spectral radius of A using the Gresham spelling problem, Gershgorin circles theorem. So find the bounds for the spectral radius. So you understand this question?
Given matrix A, find the bounds for spectral radius of A using the Gresham circles theorem.
What is a spectral radius? Do you
Spectral
remember?
radius, yeah, that is with our values.
Yeah. What is the definition of a spectral radius? It's the maximum absolute eigenvalue. You forgot?
Yeah, maximum absolute eigenvalue. Yeah, yeah.
Yeah. Okay. So we can try this example. Now people are coming. Why? Okay. So, oh, forgot what happened.
Matrix is given.
Yeah.
Given matrix.
Okay. So we're given find the bounds for spectral radius using Gresham circle theorem. So what is A?
411
Let me
0
see
2.
again. 411021
Okay.
minus 209. Anyway, is it right?
Yeah, yeah. Minus
Okay, try
209.
to find out the. Oh, no, we don't need to find out eigenvalues, right? No. Okay. So what is the row sum?
So sum is 5.
P11, P22, P33. Can
So
you tell me?
6, yeah, 6, 3, and 11.
11, yeah. And what are A11?
A11 is 4,
Or
2, and 9.
9? Yeah. Okay, so how many eigenvalues A has? A has three eigenvalues. Every n, okay, whether complex number or real number, but always A has n eigenvalues. Do you know that? By
Okay.
characteristic polynomial equations. Anyway, so what is lambda minus? So lambda 1 is the first eigenvalue, let's say. So what does it say? So all eigenvalues lie in this region. Okay, let me see once. Wait. Okay, yes. So what is, so if lambda is any eigenvalue, we don't care. Okay,
Hmm.
any eigenvalue of A. Okay, then lambda minus 1 should be less, lambda minus 4 should be less than equal to 6. Is it fine? Lambda minus 2 is less than equal to 2, 3. Lambda minus 9 is less than equal to 11. Do you understand this?
Yeah, as per the Gregorian theorem.
Yes. So is it by rows and it gives you, so what does lambda minus 4 is less than equal to 6 implies? Let me draw a graph. Is it? Either we take a smaller, why it's so big? Okay, so here, so big, this is, anyway, lambda is real or complex? Plot the graph of it. The first thing is lambda minus 1 is less than equal to 3, lambda plus 1 is less than equal to 4. Okay, so we may draw this graph. I can show by picture. I think so. Okay, so if you draw the graphs of them, let's say a big graph, I would say. Okay. So lambda minus 4. What is circle? Circle of radius center 4 and radius 6. So 1, 2, 3, 4, 1.9 and 11. It should be big. So much big. Oh my God. It's like so big. Okay. So we have 4 radius. So it will be 1, 2, 3, 4. Okay. And we have 6. So this one, this. So it starts from 4, 1, 2, 3, 4. It starts from 4 and you take 6, 1, 2, 3, 4, 5, 6. So it will be like 3, 4, 5. 1, 2, 3, 4, 5, 6. Yeah. Similarly, 1, 2, 3, 4, 5, 6. 1, 2, 3. Yes, so it's like this point here. And similarly, this point here. Okay, anyways. And 1, 2, 3, this point here. So it's like this circle. Okay.
So 4 from 4, we have to take as a center point and go up to
Yeah.
6 as a dia.
Yeah. Okay. So this is the, this one, this first one. What is the second one? 2, 0, 3.
Lambda
So
minus
2, you start with 2 and you just take 1, 2, 3. So this 1, 2, 3, this one. 1, 2, 3. This is 5. And 1, 2, 3. So 1, 2, 3. It's like this. Okay. So it's like this. Okay. And lambda minus 9 is less than equal to 11. Which one? 9, 6, 7, 8, 9, 10, 11. This one is 11. So 9 is here, so I use another color, maybe orange is good. 9 is here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's a big one. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's a big one. So where it goes here? Almost 3, 7, 8, 9, 10. So maybe here, somewhere here. So it's like this. Okay, wait. It's quite complicated. True, true. Anyway, so it's like this thing, and it's like this thing. Anyway, so but yeah, yeah. So this is the third one. Okay.
Yeah.
So lambda must lie at least in any of these circles. So what is the union of these circles? This big one.
Yeah.
So what does it say? It's saying lambda, all the eigenvalues lie at least in this big one, big union. So it's, so if you go 9 to 11, then it will be 18. And here, what is the value? -1, -2.
-2, 9,
What is
+2.
this?
Yeah,
9
-2.
minus 11, -2,
Minus
let's
2.
say.
-2.
Yeah. So at least all the eigenvalues lie between -2 and 18. That's clear that in the big circle. So eigenvalues, if they are real line, if the lambdas are real, then they lies between -2 and 18. All lambdas. Okay, if lambda is a real number, you know what are complex numbers?
Imaginary.
Yeah, yeah, yeah. If lambda is a real number, then we can say that lambda always lie between -2 and 18.
Mm, mm.
Okay. The Yes. Now we tell about the yeah, we have not used the first one. What does it say? First theorem, Gershgorin circles theorem. What does it say? Okay. So let's say this using, let me write using Gershgorin. No, I have less battery. Wait a second. Using Gershgorin circles theorem. Circle theorem. What does it says? What does Gershgorin circles theorem says? Can you tell me, Shravan?
Yeah, lambda max should be less than the largest like value.
Yeah, so what is the largest sum? Row
Largest sum
sum.
is 11. 11 is the
Yes.
largest one.
And okay. And it also says about another thing, column sum. Yeah, so what is the largest column sum? 11, right?
Sum also 11. Yeah.
The absolute value of lambda lies in between these terms. Yeah. Okay. And okay. So the Gershgorin circle theorem says about this. Our previous theorem says about this. Now, so it implies that if lambda is real, then -11 to 11. Am I right? Yes.
Yeah.
So this theorem says that. Okay, so we can use another thing is that we can also use the same theorem, above theorem for columns. Okay, this theorem for columns. So what does column version of that means? That, so instead of P11, you use another notation, maybe for columns. What is the column sum? 6, 11, and 3. So column sum is also same, right? Row sum
Same.
and
Yeah.
column sum are just same. So
Same. Yeah.
it's by column theorem also, this will be like, if you take column sum also, then this will be the same interval. Now, now you are getting some intervals. Now you have to find the bounds on that. So which is the most correct using these things, using these two things, these two intervals, can you find the bound on the largest eigenvalue? Yes, tell me.
It should be below like minus 11 from the lower side, and upper side it can go up to 18.
It can go up to 18. Then it not satisfies Gershgorin
Oh,
circle theorem.
Gershkovin theorem is okay, maximum of 11 only. Okay.
Yeah,
Hmm.
it is saying
Yeah.
about that minus 11 to 11.
11,
But
yeah.
other theorem says that minus 2 to 18. So which one is such that it satisfies both the theorems, both the inequalities? What lambda I should take? What lambda? Okay, let me write. What lambda I take, we take such that it satisfies.
So it should be minus 2 to 11.
Yeah, that's good. Minus 2 to 11.
Um,
11. It can lie between these things. Okay. And let's see if there is answer like that. Oh, sure. Minus 2 to 11. There is no answer like here. They are saying about the minus 1 to 9. Yeah. So which one is the correct one? Tell me. None of these or not?
Actually, it should be,
Think
it should be,
carefully.
yeah, minus 7.
Means which one is correct up to like not the exact bound, but yeah, the maximum eigenvalue can lie. So your answer says that row A can lie between minus 2 to 11. Yes. Now, which one is fine? Which one is fine interval for row A? Is this correct or not?
Likely,
Can row A lie between minus 1 and 9?
yeah, likely because
Is it a strict bound? It seems like it's a strict bound. It's no, it cannot be correct, right?
okay, okay,
Yeah. So either you take a bound which is like big one than this, either you take this bound minus 3 to 18, then it's fine because row A can lie in between, but you can't is small the interval. You can't make it small. Yes.
okay,
So
okay.
second one is correct. Tell me.
Second
No,
one is also on the higher side. Third one is also on the higher side. Yeah.
you have to take the big than this minus to
Okay.
11 big
Okay.
interval.
So then none of this only will
None of
match.
these is correct. Yeah. So you know the techniques what I shown.
Yeah. Yeah.
How
Now it's clear. Very clear. Yeah.
very
So
you need to understand it. Yeah.
yeah. But
So
is
what
that
you do, you
only?
apply these three theorems and take the intersection. What we have taken? Intersection of
Mm, mm.
circles. Here we have taken union.
Yeah.
Because union is giving this big circle,
Yeah.
So once here we also taken union, but all the commands are same, so don't worry. But union you should take. At last you will take intersection. Any doubts, or I can discuss some another question like that? Similar question.
It is clear now.
It is clear? Okay.
Yeah.
Suppose f of x be a polynomial of degree n, then which of the following is correct? Do you know this operator? Tal operator.
Forward. Forward. Yeah.
Okay, so what is the definition of this?
Del
What is tal fx? What does it mean?
del fx plus h. Fx
Yes.
plus h minus f of x.
Now tell me which option is correct. Fx be a polynomial of degree n, then how does it look like? Fx is polynomial of degree n. Okay. Then how does it look like? Fx is en. Yes. Plus a1 x plus a naught. Right? What is del fx? What is del fx? Tell me. So it's like, so let's try with some n equal to 2. Okay. Then fx is a3x cube n equal to a2x squared plus a1x plus a naught, right?
Yeah.
Then del fx is what? A2 minus, is it correct? Now, what can you conclude from this? This a2x square term will got cancelled, right? So what is this? A2h square plus 2a2xh. And this also got cancelled. Yeah, a2h square. Yeah. So what you can conclude is that as you are proceeding towards this thing at the end, then you are getting this x square term. So del fx produces a 1 degree less polynomial. Del fx makes polynomial degree decreases degree of polynomial by 1. Okay.
Yeah.
So what does del to fx do? Decreases degree of polynomial by 2, right? Del 3fx decreases degree of polynomial by 3. So if polynomial degree is decreased by 3, then what is the degree now? 2 minus 3, it is minus 1. And minus 1 degree polynomial is 0, okay? So answer is, so del 3fx is 0. Okay?
Yeah. So like del 2 up to del 2 fx, we will get a constant, and del 3 will be 0. Once we go to del 3, it will be
Minus
0.
1 degree. Yeah. Any question?
Now coming to that other problem, like what we were seeing
Yes. Tell
question.
me now in this. For n degree, what you do? What does del fx do? Del fx decreases the polynomial degree by 1. So if the polynomial degree is n, then it co decrease by n minus 1 by del 2. It decode decrease by n minus 2 and so on. By del n, it goes degree by n minus n, which is 0. And 0 degree polynomial is 1, constant. So you have to apply del n plus 1. Okay, then it will be minus 1. This implies that del n plus 1 fx is 0. Too fast to understand or it's easy? Any problem?
Del n plus 1 and complex. Yeah.
Del n makes the 0 degree polynomial, and 0 degree polynomial is a constant polynomial. You know that?
Yeah.
What is a constant polynomial? C, any C, right?
Yeah.
C x to the power 0. X to the power 0 means 1. So C into 1, C. But what is a negative degree polynomial? It's just 0, right? 0 something.
Okay. Okay.
0 x inverse, whatever you write, but it is 0. But you can't
Okay.
write C x inverse if C is greater than 0. That is not correct. Okay.
Yeah. Clear. Yeah.
All right. Which of the following is correct? So what is the correct one?
No,
Which?
previous one is, yeah, that one.
Yeah. Which of the following is correct? What is E operator? Do you know that?
Shift, shift operator.
Yes. I think okay. E. EFX, what does it do? Oh, let me write the first statement. What is backward difference? E. You know this? Del E. So del E is basically, so you just apply like this. Del, this is inverse del kind of. What is the definition? Is it right? This is E.
That
I
is
applied this first. Okay.
okay. Okay. So E is f of x plus h. Yeah.
Yeah, fx minus h. You separate it. Now you apply again. Okay, sorry, it is not the correct one. Yeah.
Yeah, E should
What
be
is
f of
this?
x. E is f of x plus h.
Yeah, fxx plus h. Yeah. What is this? Is it correct? See.
Yeah, inverse. Okay, yeah.
So what is this? What is this? Can I write it like this?
Yeah, del. Yeah, forward operator.
So which one is correct? First one is correct? No. Okay, E del plus one. What is E del plus one? Tell me. E fx minus h plus one, right? Now EFX minus H plus 1. Now EFX is what?
E of x is
This
f
one.
of x plus j, x plus h.
So is it correct? No. First option is not correct because it is del fx plus 1. Right? Second, what about second? Del E plus 1 fx. Okay, so you apply with del E fx plus fx. Okay, so what is del? Also, you apply E del fx plus h. Okay, plus fx.
Whether it is del or the other one, operator
Which one?
wise. And the question says the second option is del or
Wait. Yeah.
okay, it
Oh,
is
sorry. It's the inverse one, right?
yeah, it's inverse.
This you are saying about?
Yeah, exactly. Yeah, yeah, yeah.
Okay, so what is this?
So now that is del means one step backwards. Here inverse is x is h minus.
Is it? Yes. So this is not correct,
No,
right?
no, 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 no. Once again, once again. So
See,
that del fx is fx minus fx minus h. No? Now
hmm?
it is not the other one. Like when we are putting the inverse, it should be fx minus fx minus h.
Yeah, yeah. Then okay, so you are applying this del on this thing, but you replace x by x plus h now because you are applying on x plus h. So it's x plus h minus h, which is x. You don't understand it, or
Okay, just to clarify, that is
okay? So
NATLAB.
what is del fx does?
Okay, fx minus h. Yeah.
What is del fx plus h does?
Okay, what is
You
fx
replace fx by x plus h.
minus
This
fx?
and this one. Just I'm replacing this.
Clear, clear, clear.
Okay,
Yeah, clear.
right. So B is not correct. What about C? Do you know this delta operator?
Delta is the average. Central operator.
Okay, so del, it is, what does E half means? Is it? Yeah. What is EMFX? X plus MH.
X plus image. Yeah.
What is del half? It is Fx plus H by 2 plus H by 2 minus Fx plus H by 2 minus H minus 2. Right? This is a
Yeah.
central operator.
Central operator. Yeah.
So Fx plus H minus Fx. It is del F. Right?
Yeah,
So
that
is
is
this
clear.
correct? No, it's okay. What is del E? Wait a second. What is del E? Del E. X plus H. Yeah, so it is basically del Fx. Do you know? So it is correct. Now ask if you have any issue.
Okay, the last one only. Okay, del Fx plus H is Fx minus Fx minus Fx minus H.
Yes, so it is basically Fx plus H minus Fx plus H minus H. Yes, which is Fx plus H minus Fx.
Clear.
Okay. So C is correct. Okay.
Yeah.
If Fx is known at the following data points, then find F.5 using Newton forward difference formula. Do you know what is Newton forward difference formula? Should I recall?
Yeah, please.
This is third backward difference find out. Okay, let's recall that. Newton forward difference. Let me wait a few minutes. Newton, just recall forward difference. I think we have discussed in the last tutorial.
Yeah.
Do you remember the formula or no? This question we have discussed already.
Yeah.
It is cute. The earlier one we have discussed is Newton divided difference. No, I think forward difference we have also discussed.
Forward difference, you highlighted that equation.
We have discussed, yeah.
Yeah, you highlighted the equation.
Okay. You have not done the questions on assignments from that formula, or you have done that?
Yeah, I have done that. But forward difference.
Okay, I recall that for the time being. What is that? If you remember correctly, then okay, so you have.
So last assignment, forward difference was not the okay, not there. Only divided
Do you
difference they are
remember
asking.
this table X, Y, del 2Y? That I say you about this if you have X1, X2. Okay, X0, X1, X2, X3. Then you take these triangles. Do you remember?
Yeah, that is clear. Yeah,
Okay,
that
so
was
I don't write here. X3. Here it is Y0. Do you remember this? Y0. So in forward difference, what you do is Y1 minus Y0. y2 minus y1. Is it right?
Yeah.
And like this, you calculate anyways. Okay, so what is the Newton forward difference? Now tell me. H is x1 minus x0. Okay. H is basically the step size, right? So here, what is the step size? Can you see? Can you tell me? H. What is
One, one,
H?
one.
Yes, 1. Okay, let's me go there.
Copy
It's
this.
1 in this question. In question. Okay, so and there is S term I have used. What is x minus x naught by h? Okay, where is that? So what is x naught? It's 0. So x minus 0 by 1, which is x. Clear?
Yeah.
So what is the formula you have? Oh, how much order they want? Using Newton forward. They have not mentioned any order, but you know the how
Yeah.
many points are there? So it
No,
will
we
be
have
how much order?
two,
It
three,
should be how much
five
order?
points. 5 points are there, means up to five orders.
It should be 5 order or 4 order?
Okay. So it starts from 0. Okay. 4.
4. Right. Okay,
Because 1 will
so the
reduce. Yeah. Yeah.
yes. So what is Newton forward formula? Newton. I think I've discussed last time the divided difference, which is similar to
Exactly.
that.
Yeah. Yeah.
Yeah, but
Divided
not
differences.
forward. I
Yeah.
have
Forward
discussed
also.
this.
No, forward you have shown the formula from that book,
Yeah.
but there was no problem at that time, last time.
Yeah, okay, okay, okay. That's why. But divided difference is different, right?
Yeah, divided difference we have done, and it was assignment also, it was divided difference only.
Okay. So what is the formula? It's y naught plus s del y naught plus ss minus 1. I think I have shown like this in divided difference also. Do you remember?
Yeah, divided difference we have done fully.
You have s. What is the value of s? And you have, okay, so what is s here? S is, okay, so what
Yes,
is s here?
it is
0.5,
yes.
because we need to find the value at 0.5.
Exactly. Yeah.
I just write the formula, you can calculate anything. S minus 3, 4 factorial, del 4 y naught. So it's just the 4 order, right? We are done.
Yeah. Yeah.
3, 4. Okay, so you can find out the value of y at 0.5 from this. Can you do that?
Yeah.
You have all the data, this thing, this thing, this, everything. You can find out. Yeah.
Yeah.
Okay. We can go to next question. For which of the following matrix power method converges quickly? Have I discussed power method before? No.
No, no.
Okay, we can go with power method.
Look, can we see the first option? Answer in that answer,
Yes.
first option. Question, please.
In the this one?
Yeah, and the question.
Wait. Fifth one.
Yeah,
Fourth
first
one.
option. Yeah, yeah. Just I want to note down that option also when I'm solving, just to clarify. Yeah,
Yeah, yeah.
and confirm. Yeah, please go ahead. Go ahead.
Okay. So what is the, okay, I discussed the power method. Maybe we can have 5 minutes break.
Yeah,
Power method. Okay. Let's wait for 5 minutes. I
no
discuss.
issue. Yeah, please. Yeah.
Yeah. Okay, we can discuss now. Are you there?
Yes, one small clarification. The previous Newton's formula I was just trying to solve
Yeah.
that. In that del del square y naught and del
Hmm.
cube y naught all are like in the first forward side only, right? First, what we can what I'm trying to tell is del y naught is y1 minus y naught. Del square
Yeah.
y naught is the first value. First value means in the sequence down. Same thing,
Yes.
del power 4 anyway, it is 0 because that
Yeah.
del power 4 by
Yeah,
the time
that
it
term
comes,
is
it
zero.
becomes 0. So del cube also, it will be the first time only.
Yeah.
Correct, na?
Del 2 y naught is basically the first term. Yeah.
First time. So all it will be first times only.
Hmm. So if
Okay.
you, yeah.
Clear,
Okay,
clear.
I can. Wait, I just check it. Okay, so what is power method? What does power method is do? It is trying to determine the largest eigenvalue and corresponding eigenvector. Okay, so it is used to find. I think this is discussed in the class, is it?
Yeah, in class it is discussed. Yeah.
Eigenvalue and corresponding eigenvector of system Ax is equal to lambda x. Okay, so I don't know how does you prove, but I can help you in solving questions. Basically, how does it find out? Okay, let's do for just one question first of all. So what we do is if you have a matrix A, say
Just to clarify, it
yes,
is used to find the largest eigenvalue
yes,
and corrected eigenvector and corresponding eigenvector.
corresponding eigenvector
Okay, okay,
of
clear,
the.
clear.
So for this lambda, there's a be corresponding eigenvector x. X is the eigenvector. Okay, so suppose you have a matrix A minus 15, 4, 3, 10, minus 12, 6, 20, minus 4. So we have to like with the Gauss Seidel, Gauss Jordan, you start with some random vector, right? So you start with some random vector 1, 1, 1 transpose. Okay, let's write 1, 1, 1. So what we do is using this initial vector, we try to solve this system y1 is equal to a times v naught, right? You multiply a by v naught and you try to find what is y1. So what is y1? Can you tell me?
Yeah, just a second.
Just solve it. So if you solve it, I just write directly because I've, yes. So you just multiply v naught with a and then you will get y1. All right.
Yeah.
And once you get y1, then you just find v1, which is y1 by m1, where m1 is the maximum of rows of y1,
Give
absolute
small
of.
clarification. Sorry to this one. The second point is minus one or plus one. Okay, it is also plus one only.
Yeah.
Okay, okay. I just put it in. Okay. So then it's correct.
Okay. So what is y1 by m1? Can you tell me? M1 is the maximum absolute. M1 is the largest element in magnitude. So what is the largest? M1 is what?
18.
Yeah, 18. So what is v1 is y1 divided by 18, which is equal to minus 4 by 9, 2 by 9, 1. Okay. So you get v1. Similarly, you do y2. Y2 is a v1. Yes. And whatever a v1 is, you use this v1 and you will get something like 95 by 9. I'm just showing the working actually. And similarly, you divide. What you do now? Can you tell me to find v2?
Again, we
y2
have to
by
divide it
m2,
by
largest
largest
value. So
value.
what is
Yeah.
the largest one? Is
Should
it?
be once again.
Yeah. So whatever you get v2. Like this, you calculate up to y9 and v9.
So here the
So how do you
largest is
stop this procedure?
95 by 95 by 9. Okay.
Yeah. So how do you stop this procedure? Okay. So what is lambda 1? Okay, let's try to find the stopping criteria. Stopping. So lambda 1 is basically limit k goes to infinity y1 by v1 r, where r is 1 to n. So what is lambda 1? Tell me. K yk plus 1 by vk, sorry. So when k, so we don't gather about the limits, but we try to find out what is y1 by v mod, y2 by v1, y3 by v2, and so on. Okay. So what is y1 by v naught? Tell me. Y1 divided by v naught. What is this? So it is y1 and v naught is 1, 1, 1. So y1 divided by v naught is minus 8 by, it's exactly same as y1, right?
Yeah, it is
And
same as
y2 divided by v1, y2 is this and v1 is this. What is y2 divided by v1? Can you tell me
one second.
the vector? Y2 divided by v1.
One second, one second.
Yeah.
It's 95 by 4, first one.
What is this?
No, y2 divided by v1 you told, no, vector
Yeah.
two matrix. Yeah,
So this matrix divided by this. So what is the
this.
answer? 95 by 4. What is the
Yeah,
value?
okay, value. Okay. That is 23.75.
23.75. Okay. And the second value?
Second value is 5, 10 by 2, minus 5.
Minus 5. Third one?
Third one again 70 by 9 only because here it is 1. The value is
70 by 9. Yeah.
it is
Seven,
7.77.
7 point something. Okay.
7.77. Yes.
Yeah. So you go like this. So you calculate y3 by y2, you get some vector, you get some vector, you get some vector, like that. Okay. You proceed like that. And ultimately, what you got is at the final step when you, okay, let's move it. So what are you trying to find is the limit of this sequence. So it's kind of a sequence, right? So for k is equal to 1, for k is equal to 2, for k is equal to 3, you need to find the limit of this sequence. So where it converges, it will give you the maximum eigenvalue. So what you get is finally, as k approaches to infinity, mod lambda is equal to 19.977. You just check it. So we finally have mod lambda to be 20. Okay, if we round off basically to 3 significant digits, then once you get lambda, you can find out the eigenvector. Okay, once you get the lambda, ax is equal to lambda x. Okay, so how do you find out the eigenvector after that? So yeah, so vk plus 1. Yeah, so at which stage? So if you are getting closest limit, if you're getting limit at say k is equal to 9, then v tan is the eigenvector. Do you understand the proof? Do you understand the question now? Feel free to ask.
So if like when we are proceeding like
Mr.
this
Atal.
at K
Yeah,
1, 2, 3, so at K 9 we will be getting lambda as 20, approximately 20.
yeah,
So the point when we are seeing whatever the value we are getting with respect to x, like ax, the x will
yeah,
be our vector, eigenvector.
yeah. So v9, v tan will be your eigenvector if you are getting at 9. So you have to continue. You have to, how do you find the limit of a function, right? So you have to see at which step they are becoming closer. So you can stop at that point.
Okay, so all values should be closer that way.
Yeah,
Okay,
yeah,
okay, almost similar.
that
Okay,
should be
okay,
it. It should be.
okay.
Okay, so okay, so let's see that what the question is. So which the power method converges quickly. Oh my god. So for which eigenvalue, for which of the matrix the power method converges quickly?
Previous question is okay. That is the fourth. Oh, fourth we have completed. Though now this is in fifth. Yeah.
Yeah, so here how do you do that? Okay, so if there is a proof that if second eigen, okay, mm, lambda 1 is lambda 1, and if wait a second, if the two eigenvalue, okay, okay, the vector. So here, what are the eigenvalues? Can you tell me in the first matrix? Eigenvalues. Yes, tell me what are the eigenvalues?
Lambda equal to 10 and minus 1.
N and minus 1. Okay. Let me see this question. Actually, this is different.
Question is which of the following matrix the
Yeah.
power method it is converging quickly.
Yeah. Mhm. Or which, okay, is this question making sense or not? What is lambda 2? Doesn't make sense to me. Yeah, I have to think about this question. Doesn't making sense. How, in what sense the convergence? I will think about it. Okay. Is there a similar question like this in assignment 7? I think no.
1 second.
See.
Yeah, just 1 second. No, it is not there. I think power method is not there for this week.
Okay, that's good. Okay, I will think about it and let you know
Sure, sure.
in
Yeah.
email or something like what this question is saying. I have to see. Yeah, so here, can you solve it now? This is easy, right? I've done this. Okay. How many questions? We have a lot of questions pending. Okay, so del 2 by E x cube. Can you do that yourself
H
later
equal
on?
yeah.
Okay.
So
So
it is
consider the,
two times
yeah,
forward and one divided by shift.
yes.
Yeah, with H equal to yeah. Just can I see the question one more time? Just I will
Yeah,
take.
yeah.
Okay, okay, thank you.
Okay. Consider the following table. Assume that third backward difference is constant. Find the value of A. So here, what approximation you have to use? Can you tell me? Backward difference, right?
Yeah.
Approximation. Okay, so let's me write the formula for that maybe. Okay, so backward. Should I share these notes also after the class in the links?
Yeah, it will be better if it is there
Okay.
because otherwise I'm trying to take
Have
some
you seen the
screenshots.
before? I've not uploaded like after tutorial 2. I was
Okay, okay.
like,
Because the videos I could see
okay.
this one I am since I'm noting it in my notebook. Apparently I
Yeah.
am taking some screenshots also. That's why.
Okay, okay. I will upload it. Okay, so what is backward difference approximation? It's similar to the forward difference, except some changes. Newton backward. So has it been discussed in the class? Backward difference approximation? No.
I think both forward and backward like outline was given. Outline means like the equations wise.
Okay. Backward difference, they're not told me it like. Okay, so what is the backward difference actually is you have the formula for backward difference is yx is equal to like the previous one, yn plus p del yn. Here it doesn't start with y naught, okay? How many entries we have in this? 5. So it will be how much degree? 4 degree.
Yeah.
Del qyn plus p plus 1, p plus 2, p plus 3 by 4 factorial del 4 yn. Right. Okay, so what is, how do you calculate it in this? And h is x1 minus x naught. So what is h? Can you tell me in this question? What is H?
Maybe 5.
Yes, H is 5. Yeah. And what is, okay, so what is del yn? Let's see that. How does it work? It's like similar one, but are we doing that way or del y not? Are we doing, what is del yn? So what is the definition of del operator? Do you remember? Yeah. Okay. And del y naught is y1 minus y naught. Okay, the table will be similar almost. Okay. So what is x? Let me write this first. I will solve it. X, y, x, no, x, y, del, del y, del 2y, del 3y, del 4y. Okay. Who is P Sudhakar? Why is coming again and again like? Okay, so tell me what is del x 25, 30 to 45. 25, 30, 35, 40, 45. Okay.
Yeah.
And what is y? A 0 0.5, 0 0.5736. Three six. Wait a second. What happened? 0.6428. Okay. I should next time I will copy paste all the questions here so that. What is del y? What is del y? Like you do earlier, right?
So
0.5 minus a.
minus A. Yeah.
You just subtract it, right? You just subtract it. You just do that. You just do that. So here, how many points? Huh? Oh no, is it? No, it's not correct. Wait, what I have done? Have I done? Oh, this, yeah, yes. Now it's fine. How many form? 4 entries, 3 entries. So this will be like, wait, this, right? And there will be 2 more entries. And there will be 1 more entry. Okay. You understand?
Yeah.
Now what you do, S is here, x minus xn by h. So what is xn here? Can you tell me what is xn? Xn is the last point. So 45.
Yeah.
Okay, so it is S. Now you use the formula, you have everything now or not? So what you do? What is the difference? Can you tell me now in the formula? Instead of the in comparison to the forward difference?
We are going from the big backward. No? It is there.
Yeah.
We are going with x naught. Here we are starting with
So
x
here
naught.
in the forward difference formula, you were having y naught here, and you
Yeah,
were
yeah,
taking
yeah.
only the first one.
First one in the top to down. So now here
But here
bottom
you
to
are
up to
taking, yeah,
full
bottom
top.
ones, last
Bottom row.
ones.
Yeah, yeah.
Yeah. So here we are taking, let me
Yeah.
highlight it for the, here we are taking these, okay, the last ones,
Exactly.
right?
Yeah, yeah, yeah. Exactly, exactly. Yeah.
And similarly, you just, you know these values, you know these values. And what is the value of x here? Let me see. What is the value of x here? Can you tell me? Assume third backward difference to be constant. They are saying that it is constant, means del 3y is constant. Okay. Del 3yn is a constant, then find the value of a. What they are saying about this del 3yn.
Del 3y, if it is constant, means we need not even calculate del 4y, it will be 0.
Oh, so that is the thing. Actually, the question is not using the backward difference approximation. It's just saying about the that third backward difference is this, and you just calculate from this what is del 3y n is equal to c. You just put some constant. Assuming
Okay.
third, find the value of A. But they should be giving you that constant. I think so. Ha ha ha.
Or
Okay.
shall we
But
put del
wait a
4 y
second.
equal to 0? I will get A.
Wait. Yeah. You should put that. So you are saying about del for y, is
Yeah,
it?
del 4 y, because del 3 y is constant, mean next step only it will be 0. So del 4 y
Del
I can
5
give
y
you.
will be 0, right? Not del 4 y. Del 5 y is 0.
Is it correct? Because del 3 y is constant means del 4 next step, if I am taking del, that should be 0. No? Is it
Okay, so you are saying that del 5 y is not 0?
del 5 y? Anyway, del 4 y itself will be 0. That is
Why? Why it should be 0?
because del 3 is constant.
Wait a second. Oh, yeah, you are right. Yeah. Del 3 y is constant. Okay. So that's why it is 0. So if del 3 y is constant, then it is 0. Oh, okay. Yeah, you're right. So what the question is saying that del 4 y should be 0. Yeah, because del 3 y is constant. Correct. So from that, can you find A?
Yes, it is possible. Yeah.
Yeah. But you don't need to use this approximation in this question. Yeah. Polynomial. But you know this table. From this table, you can do. Okay.
Yeah.
Yes. How many people are there? Only two. All right. So what is, yes, from the following table, find the number of students who obtain less than 45 marks using Newton's forward difference formula, who obtain less than 45 marks. So in between 30 to 40, you got 31. In between 45, 40 to 50, you got 42. Okay, so what does Newton forward difference formula gives? It's trying to find out the. Okay, so you have to find. Can you understand this question? Can you tell me what is trying to say? Anyone? Yes, tell me
Find
what
the
the question is saying.
number of students who has scored less than 45.
Yeah. Yes. Then.
Mayuresh here, probably this intervals, we have to take a mean value of the interval for x
Yeah.
values, and then y values will be the second row. And then for less than, okay, but less than 45 will be reported
Oh, so you are saying
directly
that
under this.
you can transform into the previous table, right? 30, 40, 50, 60, 70, 80. See? So between, so you can
Okay, so
interpolate it, is it or not?
I'm not
Okay,
sure.
so what? Okay, so let me write in precise way actually. Can you do by this way 30, 35, 40, 45, 50, 55, 60, like this 80, and you have a big table 31, 42. So you have at 35 also you have 31, not 42. At 40 also you have 31 students, right? Then at 45 you have 42, 50 you have 42, like this. Then you try to interpolate using Newton forward difference formula and then try to find out what is the value at,
One small doubt. Actually, we are telling 30 to
or yeah,
40.
yeah.
40 again, there is a common will be
Oh
there.
yeah, it's, I think should be. I would prefer this one. I think so. Not at 5 step. Just take at 10 steps. That will be more better. 30, 40, 50, right? And 30 to 40 you have 31. So I just write 31, 42, 51. I just transform in this way. Is it correct or 70? Or I just go till 70 because not more than 80.
May not be, actually, yes, it may not be correct because at less than
Yeah.
30, no? we are counting 31, but there is 30 to 40 also. No, that where are we counting?
So if marks are 40, then there are 31 students. You are saying.
Yeah, but then now we are counting for less than 30, 31 students. So that means
Okay.
we
So
are
what is
losing that 30 to 40.
okay? So what is the approach for this question? Tell me. How do you approach it in this? Find the number of students who obtain less than 45. How do you use Newton forward difference formula and like that? Any ideas? What does Newton forward difference formula do? It tries to find the approximation polynomial, like any other polynomial from the given data.
Yeah.
And this data is given to us in this form. In this form, we have first time seen this data in this form. Okay, let me wait
These
or think
ranges need
about
to
it.
be converted into a discrete values,
How?
but that how it is, I'm not sure.
Yeah, it should be discrete. That's why I was doing that. Okay,
No, but
let
that
me.
also, okay, that's what I said. And whatever we have done right now may
Yeah.
not be correct.
Mhm. Let me see what is the possible like for these type of tables. So you have basically, wait a second. One possible approach is, of course, this, but another approach, think about it. Okay, let me put it this. Okay, so here, what? Yeah, so here the thing is that, can you have idea or I should tell? What is the idea behind this question? So this way I was trying to do 40, 42. You are saying Mayuresh, it's not right, right?
Okay, but
But if
I
I do
actually
this
have
way,
given explanation. So yeah.
if I
No,
do,
I was just telling
so
that
for
when
30,
you
I
are
can
doing,
write 31. Is it right?
no, if okay, 30 we cannot write 31 because suppose there is
Okay,
suppose
for
one student
40,
got
I can write
31 marks.
31. Can I start with 40, not 30?
Yeah, this is correct.
Why? You are saying this is correct.
Only thing is we are also there is a pinch of doubt here because of less than 30 marks also some people would have opted.
Yeah.
So that also is coming over here
Less
in
than
less
50,
than
how
30.
many? Less than 50, how many? Can I write 42
This will
or
be
any?
delta difference.
Huh? No,
Can we take a delta difference between number of students at every step? So
should be
42 minus 31.
73.
11.
Uh,
Oh, yeah, you are correct. It will be as addition. It will be addition. 73
yeah, it's addition. Yeah. And below 60? Below
plus
60?
51.
Yeah, plus 51.
Plus,
So 1, 2, 4. And like this. So can you
yeah,
make the table like this and you can try to find, so just a function. So what is X is doing?
yeah,
Y is trying to calculate below these values, below marks. Oh, yeah. So it's a tricky one, but yeah, you can do that. Okay. Consider the following data and find the value of del to f tan. Now you can tell me directly. What is del f tan?
F10
Yes,
minus F9.
f tan
F10 minus
minus,
F5. F5.
which is 3.8 minus
1, 2.2.
1.6. So it is 2.2.
2.2.
What is del to f tan? Yes, del
F10
f tan
minus twice of, okay,
f5.
del of F10.
Del of f tan is what? F tan minus, yeah, f tan minus twice of
F5.
f5 plus
My
f.
plus F0.
What is the value of it? You can calculate. F tan is 3
Yeah,
point plus 1. Is it? So what is the answer? 1.6 or something else? Am I wrong? I think I'm right. None of these.
Just can you slightly go?
Yeah.
Yeah. Yes. Okay.
Okay.
It is, but why that answer is differing? None of this is okay. The value what we did is correct. 3.8, 2.6, 2.2. Whether
Yeah.
F10 is 3.8, okay, that is 3.8.
This question is a part of assignment, and I got answer as point. This is Dale
Are you doing assignment with
backward.
this time? Oh,
Yeah, there is a question on the assignment. So I got
okay.
1.6, and which
Okay.
is actually option there.
It is an option there. Okay.
Yeah.
Okay, then it's good. Find the value of del to F5. Tell me. Del F5. So del
Okay, this also
F5.
is the question there.
Tell me how to do this. F6 minus, oh sorry. F10 minus
Del of
F5.
del 5, F6 minus F5. Yeah,
So
F10
del
minus
of.
F5.
So what is this finally?
F11.
F15
F15 minus twice of F10
to F10. Is it?
plus F5. Yeah.
I think I'm confused. F15 minus F10
Twice of
minus
F10
F10
plus F5.
F5. So it's same as del. Now you can find out this.
No, there was no F15 there, no, in the earlier.
Okay. Yeah. So you can find out this. I'm not going to solve it. Okay, I'm done.
Just can we see that? Whatever
Yeah.
we did.
It's a similar type of question in the assignment, or
Exactly same question, not
so
similar.
I should not do this.
No, but there is no answer here.
Okay.
There is no answer. These answers are different than the assignment.
Okay,
So
the digits
no
are
need,
should be say
no
different.
worries.
The digits are different. Hmm,
Not yeah, entirely it is different.
okay. If you have any questions, let me know.
Oh, but can I ask one question?
Yes.
Yeah, actually, this is basically from assignment. I did not understand the question.
Okay.
So can I read the question?
Yeah.
Yeah, we need not to solve, but can you just at least give the approach? One is no, it is told that determine the state size that can be used in the tabulation of f of x is equal to sin x in the interval 0 to pi by 4 at equally spaced nodal points, so that truncation error of the quadratic interpolation will be less than 5 into 10 raised to minus 8.
Okay. Yeah. So what is the
Yeah.
truncation error? Quadratic
Yeah.
interpolation.
Yeah. So truncation error in quadratic, what I understand is sin x series, Taylor series we can put,
Yeah.
and we can cut at the quadratic. So x square term we will
Yeah.
cut.
Yes.
Yeah, but then further, okay, I'm not able to. Okay, at equal to step size that can be used in the tabulation of source. Okay, not able to understand. Anyway, I can do it. Just wanted to ask whether like same thing, right? Taylor series and then truncating at quadratic.
Hmm. You have to write Taylor series expansion. You see, understand the question once. If you have any doubt, you can email me. I'll help you.
Yeah. There is one more doubt I'm having in question
Is
number
the
8 of the
assignment questions
assignment.
correct this time, or there is some problems?
This time assignment questions are matching with the this week's lectures
Okay.
probably. Yeah.
Okay. But technicality, you should check is the answers correct or not.
Yeah. There is one more question where it is told to find out the unique polynomial of degree 5
Yeah.
or less corresponding to and it is given f of x is given f of x0, sorry, f of x0 is given f dash and f double dash, f dash and f double dash of x0 is given. Likewise,
Yeah.
f of x1, f dash and f double dash is given, x1s,
Yeah.
and
Yeah.
they're asking us to find out the coefficient of x raised to 5.
Yeah.
Yeah, but is it from the Newton's divided difference?
It's, I think,
No, because we are talking about f
what is
dashes.
given there? F0, F dash 0, F double dash
F
0.
f dash and f double dash for x0 and x1 is given.
Is there a step size given?
Step size is not given, but probably from steps x0 and x1,
I think it's
x0
from
and
Taylor
x1 is given.
series, because what you write, how do you expand the
X0 and
Taylor's?
x1 is given.
What is Taylor series expansion? Fx is F0 plus
Yeah,
X F dash 0.
h into f.
Is it?
Yeah.
Okay, like that.
No, but only why I ask this question? No, because it is told to find out the coefficient of x raised to 5, and
Okay.
we have been given only up to f double dash.
Okay, okay, not X
Yeah,
cube.
that,
Okay.
yeah. Otherwise, had it been only f x raised to 3, I
Okay, so
would
it's
not have
saying
asked this
about to
question.
find out 5-degree polynomial, or?
Yeah, 5 degree. It is told to find out 5 or less,
Okay,
like
so
that
you
it
can
is
assume
written. But finally,
a 5-degree polynomial. A5, A4,
yeah,
X4, A0. Then you just find F dash X, F double dash X, and then find out.
okay. But the number of questions and number of inputs are not matching. Anyway, I'll see it, but it's
Okay,
not.
okay.
Number of inputs are not matching
Just
with
check
respect to the
whether
number of
this is
equations.
fine or not. Yeah.
Okay.
Have you seen the recorded lectures, tutorials?
Yeah. This week's right.
Yeah.
Yeah, this week's I have gone through, but whatever questions I asked is okay. I could not get it through the lectures.
Okay. You have not attended today's tutorial full, I think. No. No one is coming.
Actually, I have a small issue. Actually, for me, no, there are four subjects I need to attend,
Okay.
and all lectures are at
Should
three
I
to
change the
between three
time
to
of the
five.
tutorial, or I
No,
can
but
change it?
probably other people should not be affected. That's why I have not requested you.
Shavanan, this time is fine for you?
Yeah,
Or
no issue for me. Yeah,
will be
probably Mahesh,
really
you
great.
can, yeah, you can.
I was planning to change the timings to Friday
I have
evening, like.
requested even I have requested other tutors. Even I have not asked Yash, but I have requested other tutors and they have denied. That's why then I thought that I will not ask. It will
Okay,
be
I
really
was
great if you
thinking
can
because
change.
in weekends I want to be free of anything.
No
Yeah.
problem. Even Saturday evening also will be okay. Mayuresh, what is your timing for
I
Saturdays?
am okay with any. I am okay with
Actually,
only
in
any
my
time other than
I'm
3
out
to
of
5.
the country, and
Okay, okay.
the
You are in
the
Australia,
timings
right?
are 7:30 to 9:30 p.m.
Oh, now it is 7:30 to 9:30. Uh-huh. So it will be too late if we are dragging here.
Yeah, so maybe
You
in
please,
Friday I
Yash,
can.
if possible, you please change. I am okay with any time other than 3 to 5.
Other than 3 to 5. Okay. I was thinking on Friday from around from my timing 6 to 8 p.m.
No, actually that
Your
way
6
we
to
will
8
be in
means
office.
Indian. No,
We will
in
be in
that case, you
office.
will be in office.
No, no. In Indian timings, it's like 1:30 to 3:30
yeah,
p.m.
yeah. We'll be in office by the
No,
time.
1:30.
You will be on
We will
office. Okay.
be-
Okay, so
Our
it's not
office
good.
closes by 5:30, so we will reach by house by at least 6:15 only, both of us.
You can
So you're off
also Saturday morning also is okay. Yes,
Saturday morning.
morning. Saturday
Yeah,
morning, Sunday morning, Sunday
yeah,
afternoon, Sunday
yeah.
evening,
Saturday,
anything is
Saturday
okay.
morning will be more ideal.
No
Mayur's
Sunday,
calling.
not Sunday
Yes, yes,
morning.
yes.
Okay,
So
one day.
Saturday morning, can you just keep it?
Yeah,
For you,
Saturday
Sunday
you
more
morning.
yours
ideal.
time can be 11 or 10 hours. That will
Exactly.
be -2 hours,
-4 hours.
Minus
minus
four.
4 hours. Is it?
4.5. Sorry. Yeah.
Okay, okay.
So
10 or
yeah.
11 also is okay. 11 to 1 also is okay.
Okay. So 11. Okay. 10 or
11 to 1 means
11.
it will be afternoon for him.
Yeah.
Otherwise,
Yeah.
yours
Yeah.
12 also is okay, so that it will be hours 8 o'clock. Sarvanand sir, is it okay?
Fine, no issue for me. 8 will be
Yeah.
always fresh. We can finish it up. Max always in
Yes,
the
yes,
better in the morning.
Saturday morning will be really great.
Yeah, yeah.
Okay. Saturday morning. So yeah, because in night I got late sometimes. Yeah. Okay. So 3:30 to 5:30 my time in Saturdays. Yeah. That would be good.
Oh, yours 3:30 to 5:30. That means ours will be
Yours
11:30.
will
Is it
be
not?
11 to
Yeah.
1.
Okay, no problem. That will be really nice.
Yeah.
Yeah, no issue for me also. Yeah.
Okay. I will request.
Yeah.
Thank you.
Yeah. Thank you.
Okay. Thank you. Thank you.
One small request, yes, please upload that other one also, whatever we are writing in that scribbling note.
Okay.
That
Okay. These notes. Okay.
right. Yeah,
Yeah.
yeah.
Okay.
Yeah,
I
for
think I've
earlier
uploaded.
classes.
I've not uploaded the previous 3, 4
Yeah, yeah.
videos.
Previous also
What is
it
the
is there.
software you are using for scribbling? What is the notebook you are using? Yes.
It's good.
What is the note? Which is the notebook you
Okay.
are using for scribbling down? What is the
I'm
software?
using. There is a journal software. Journals.
Oh, is it a paid software?
No, I don't think so.
Journal.
It's free.
Can you show me? It is really nice. But that's why I. And
Okay.
how do you
So
write? By you are having a pad and pen, is it?
yeah, I have. My laptop is screen touch, so I can
Okay,
write
okay,
over
okay. Like
with pen.
okay,
Yeah. This is HP Pavilion. You know that?
okay,
Yeah.
okay. And software
Journal is.
is journal, is it?
Yeah. Journals.
Okay. Okay, right. Thank you.
Okay. I stop sharing.
Yeah.
I stop recording.